Happy morning, children. I am your physical science teacher. Hope you are all doing good. Today, we are going to start a new lesson in Physics Unit 4 Electricity. Electricity deals with the flow of electric charges through a conductor. It refers to a form of energy. Without electricity, it is impossible in our day to day life. In this chapter, you are going to learn the concepts of electricity and applications of electricity in day to day situation. Come, let's move on to the video session. Electricity. In this lesson, you will learn various terms are used in understand the concept of electricity, and will also learn the importance of the application in day-to-day situation. Before enter into the session, you should know what is electric current. The motion of electric charges, that is electrons, through a conductor will constitute an electric current. Likewise, air current, water current is also there. What is air current? The air is moving from higher pressure area to a lower pressure area, that is called as an air current. Okay, what is water current? Water current means water flows through a channel higher potential to the lower potential. Next, the flow of water compares to the flow of electron. You can see this picture, water tank. The water is flowing from higher potential to the lower potential. Next, you can see this diagram. Here you can see the flow of electrons. Battery, in the positive terminal of the battery, that is electric current, passes from the positive terminal, that is higher electric potential of a battery, to the negative terminal, that is lower electric potential. It is connected through the wire. Next, definition for electric current. Electric current is defined as the rate of flow of charge. The charge, it is denoted by the letter Q. So Q is equal to total charge. Time, for time, it is denoted by the symbol T. So T is equal to time taken for the flow of charge. I, current. I is equal to electric current. So net charge Q passes through any cross section of a conductor in the time t. Then the current flowing through a conductor is I is equal to Q by T. Okay, so this electric current is represented the amount of charge flowing in any cross section of a conductor. Next, we'll see SI unit of electric current. The SI unit of electric current is ampere. It is denoted by the letter capital A. The current flowing through a conductor is said to be 1 ampere. When a charge of 1 coulomb flows across any cross section of a conductor in 1 second. Hence, 1 ampere is equal to 1 coulomb divided by 1 second. Here, what is coulomb? It is a unit of electric charge in the meter kilogram per second. This ampere system, the basic system of SI unit is coulomb. It is denoted by the symbol C. Let us solve the problem number 1. Question. A charge of 12 coulomb flows through a bulb in 5 seconds. What is the current through the bulb? So, in this question, we have to find out what is the current through the bulb. What are the given datas? The given datas are charge. For charge, it is denoted by the letter Q. Charge Q is equal to 12 coulomb is given. Okay, 12 coulomb. Next, it flows through a bulb in 5 seconds. So, time is also given. Time t is equal to 5 seconds. That is also given. So, therefore, the formula current I is equal to Q divided by T. Next, you can substitute these two values, charge and the time. For charge, 12 coulomb, can write 12 divided by the time, 5 seconds is given. So, 12 divided by 5. If you divide these two, you will get 2.4. So, I is equal to current I is equal to 2.5, 2.4 into A. Here, what is A here? Ampere. Ampere is the unit of electric current. Next topic we are going to see is electric circuit. In a simple electric circuit is a closed conducting loop, or can call it as a path, which has a network of electrical components through which these electrons are able to flow. If you take the simple electric circuit, there will be a bulb, battery and a key. Okay, if you open the circuit by using this key or switch, that means we are disconnecting the circuit. If you disconnect means, so the bulb does not glow. Why? Because there is no flow of current. Okay, next, if you close the key, that means there is a flow of current. So the bulb will start glow. This is the simple electric circuit. So in the circuit, if you see this, the switch is on, the bulb will glow, that you know. If the switch is off, the bulb will not glow. Likewise, the potential difference is necessary for flow of charges as provided by the battery. Next, we have to understand the components that we are used in the circuits and what are the uses of the components and the symbols for the components. First, you can see component. Next, uses of component. And the third one is the symbol used. First one, a resistor. So, what the use for this resistor? It is used to fix the magnitude of the current through a circuit. This is the symbol can use. Next one component is the variable resistor, or can call it as a rheostat. What is the use of this component? It is used to select the magnitude of the current through a circuit. You can see this symbol. The next one is the ammeter. It is used to measure the current. You can see this symbol. Next component is the voltmeter. It is used to measure the potential difference. You can see the symbol. Next one is the galvanometer. It is used to indicate the direction of the current. You can see the symbol. Next one is the diode. A diode has various uses which you will read in the higher classes. Then light emitting diode, that is LED. It has various uses which you will study in your higher classes, that is also given in the The next component is the ground connection. It is used to provide protection to the electrical components. It is also serves as a reference point to measure the electric potential. You can see the symbol. Let's see the examples to understand the electric potential and potential difference. Suppose we take two water tanks placed at the same level of water and connect both with the tube. In this case, the water flows from one tank to the another tank? No. Why? This is because there is no pressure. Water level is same in both the tanks. So water will not flow. Suppose if you increase the level of water in one tank, does the water will flow from one tank to the another tank? Yes. This is because the water flows from higher level of water to the lower level of water, that is higher potential to the lower potential. Hence, there is a flow of water. There should be a difference in pressure. Similarly, the flow of electricity, there should be a difference in electric pressure. This difference in electric pressure is called potential difference. So, what is electric potential? The electric potential at a point is defined as the amount of work done in moving a unit positive charge from infinity to that point against the electric force. This is the definition for electric potential. Next, we'll see flow of electricity. You can see this picture. There is a positive and a negative charge. So, where is the higher potential? That is the positive terminal. So, the electrons move from higher potential to the lower potential. Next, what is electric potential difference? Electric potential difference between 2 points is defined as the amount of work to done in moving a unit positive charge from one point to the another point, that is against the electric force. It is defined as the amount of work done in moving a unit positive charge from one point to the another point. You can see this diagram. Suppose if you move a charge Q from a point B to A, from right to left, that is point B to the point A, let W be the work done to move the charge from A to B. That is for potential difference, it is denoted by the symbol V. So, potential difference V is equal to work done divided by charge Q. So, work done divided by charge is equal to, for work done, it is denoted by the symbol W, for charge Q. So, W by Q. Next, volt. The SI unit of electric potential or potential difference is volt. It is denoted by the symbol V, capital V. The potential difference between 2 points is 1 volt. Potential difference between 2 points is 1 volt. If 1 joule of work is done in moving 1 coulomb of charge from one point to the another against the electric force. So how we will write 1 volt is equal to 1 joule divided by 1 coulomb. Next one is the voltmeter. Which instrument is used to measure the potential difference as voltmeter? So voltmeter, it is an instrument used to measure the potential difference. Next, solved problem 2. The work done in moving a charge of 10 coulomb across 2 points in a circuit is 100 joule. What is the potential difference between the points? Here we want to find the potential difference between the points. Okay, here you can write the given data. For charge Q is equal to 10 coulomb is given, and another data work done, that is work done, it is denoted by the letter W. W is equal to 100 joule is given. Now we have to find out the potential difference. Okay, next write the formula for potential difference. V is equal to capital W, that is work done divided by charge Q is equal to, next substitute the values. For work done W 100 divided by charge 10. If you divide these two, you will get the potential difference value. V is equal to 10 volt. Next, we'll see Ohm's law. A German physicist, George Simon Ohm, published the relation between the potential difference and the current. According to Ohm's law, at a constant temperature, the steady current I flowing through a conductor is directly proportional to the potential difference V between the two ends of the conductor. Okay. Here, when the current increases, the potential difference will also increases. When the current decreases, the potential difference will also decreases. That is the meaning for at constant temperature, the steady current I flowing through a conductor is directly proportional to the potential difference between the two ends of the conductor. I is directly proportional to potential difference V. Hence, I divided by V is equal to constant. The value of this proportionality constant is found to be 1 by R. Therefore, I is equal to 1 divided by R into V. Therefore, potential difference of V is equal to I into R. Here, R is a constant for a given material at a given temperature and is known as the resistance of the material. Next, you can see this graph between the potential difference and the current. You will get a straight line for a conductor. So, why we are getting this straight line? Means the current increases, means the potential difference will also increases. Okay, that's why we are getting the straight line. Now we will see problem 3. Calculate the resistance of a conductor through which a current of 2 ampere passes when the potential difference between its ends is 30 volt. So this is the question. Here what do you want to find? Is resistance. So you can write the given data. Given data, current I is equal to 2A. 2 ampere is given. Then potential difference. Potential difference is 30 volt is given. Next up, from this Ohm's law, we know the formula. V is potential difference. V is equal to I into R. From that Ohm's law, you can write R is equal to V divided by I. Next, I can substitute the values. So R is equal to V. V value, potential difference 30 is given. You can write 30 divided by I. How much is given? The I value is 2. So 30 divided by 2. If you divide these two values, you will get 15 ohm. So 15 ohm. This is the resistance. R is equal to 15 ohm. For resistance, R is equal to 15. The unit is ohm. So 15 ohm. Did you get a shock on plastic wire? It is not possible. You can get shocks from plastic wires. You cannot get shocks from this plastic wires. But why? It is so. It is because of phenomenon of resistivity. Here we will use see the resistivity of various wires. Before that, you should know what is resistance. So it is an electric current that flows in a circuit as similar to the flow of water flowing through a river. In a river, branches and other particles resist the flow of water. In a very similar fashion, a circuit has elements to resist the flow of electrons. So here resistance is nothing but this property of resisting the flow of electrons. The flow of electrons or the current. So the unit of resistance is ohm. 1 ohm is equal to volt per ampere. From Ohm's law, we have already seen that R is equal to V divided by I. So here V is the voltage and I is the current. This is the resistors. Do you know why we are using this resistor in an electric circuit? These resistors are used to resist or to control the flow of electrons by the conductive materials. They do not provide any power to the circuit. They may reduce the voltage and the current passing through the circuit. Most of the resistors are made up of carbon, metal or metal oxide. So next, what is resistivity? Resistivity is the resistance per unit length and cross-sectional area. It is the property of the material that opposes the flow of charge or the flow of electric current. It is the property of the material that opposes the flow of charge or the flow of electric current. The unit of resistivity is ohm meter. R is directly proportional to L. So R is directly proportional to 1 by A. That is, A is the area of a cross section here. R is directly proportional to L by A. R is equal to rho L divided by A. Here rho is a constant. It is called as the electrical resistivity or specific resistance of the material of the conductor. Then next rho is equal to R into A divided by L. Can substitute the values. L is equal to 1 meter, that is length is equal to 1 meter. Area of a cross section A is equal to 1 meter square. Then from this above equation we'll get rho is equal to R. Do you know different materials will have different resistivity? For example, copper and aluminum will have low resistivity, having good conductors, have less resistivity. Insulators have high resistivity. The resistivity of semiconductors lies between the conductors and the insulators. Gold is a good conductor of electricity and it has low resistivity. Glass is a good insulator which does not allow the flow of electrons. Hence, it has a high resistivity. Do you know nichrome is a conductor which highest resistivity equal to 1.5 into 10 power minus 6 ohm meter. Hence, it is used in making heating elements. Conductance and conductivity. Conductance of a material is the property of a material as to aid the flow of charges and hence the passage of current in it. So the conductance of a material is mathematically defined as the reciprocal of its resistance. It is denoted by the symbol R. Hence the conductance G, capital G of a conductor is given by capital G is equal to 1 divided by R. Its unit is ohm inverse. It is also represented as MHO. Next, we'll see the definition for conductivity. So, conductivity is defined as the reciprocal of a resistivity of a material is called its electrical conductivity. Sigma is equal to 1 by rho. Its unit is ohm inverse. It is also represented as mho per meter inverse. So the conductivity is more for conductors than for the insulators, but the resistivity is less for conductors than for the insulators. Here you can see some examples of insulators. Most of the plastics, glass, cloth, sand, rubber, wood, dry air. Resistivity of some materials. Nature of the material. Conductor material. Copper, nickel, chromium. For copper, the resistivity is 1.62 into 10 to the power minus 8. For nickel, 6.84 into 10 to the power minus 8. For chromium, 12.9 into 10 to the power minus 8. The nature of the material: for insulator, the materials are given glass and the rubber. For glass, the resistivity 10 power 10 to 10 power 14. For a rubber, 10 power 13 to 10 power 16. Next, system of resistors. Here we are going to see the combination of many resistors in a circuit. Here you can see this diagram. In the first three resistors are connected in a series circuit. You can see the second diagram. 3 resistors are connected in the parallel circuit. So this combination of resistors is known as system of resistors or grouping of resistors. These resistors can be connected in various combinations. The two basic methods of joining resistors together are: first one is the resistors are connected in series, and the one second, the resistors are connected in parallel. When many resistors having different resistance values are connected in series and in parallel. Children, write the question answers in your classwork note and mark the 1 marks in your book itself. Thank you.